Hey there, welcome to a video discussing the beginning of the chapter 3 notes. We're going to kind of skim through um, pages 1 through 6. So we're going to talk about 3.1 and 3.2, which is on systems of equations. There's a little bit of stuff on matrices, sorry, not matrices, graphing of absolute value functions. We're not going to talk about matrices. That's something you'll do later in the year in Algebra 2. But let's take a look at the graph of an absolute function, just so we at least have that discussion, because I did say I want to talk about it. So I'm going to pull up Desmos right now and might slow down my computer. So give me one sec here. So y equals, and then you're going to type abs for absolute value and put parentheses. And that's x minus 5. And really minus 13. Okay, minus 13. So what you're going to notice is that the vertex is at 5, negative 13. See, if I just graph y equals absolute value of x, vertex at 0, 0. So there's a translation that's happening here. The minus 5 would imply to move 5 right. Minus 13 implies to move 13 down. So we'll talk more about translations when we meet again as a class. But that's what those things do. So we'll talk, and we'll obviously have more discussion on graphs of absolute value and transformations next time. This is in the graphing calculator. I'm just going to do this on Desmos just for simplicity's sake. But now let's move on to systems of equations. So for something like this here, 3x minus 2 and y equals 5x plus 2, you can graph each line, see where they touch. The solution is going to be the point of intersection. Sorry for the messy handwriting. Unless they don't touch, which means they're parallel, or they overlap, meaning they're the same line. And sorry, that's really messy handwriting, parallel. So in this case, they're not parallel because the slopes are different. So, and we call this a system, there's more than one equation. So two or more equations call a system, and these are linear. But we're going to look at some absolute value, which has a linear nature to it, but we're going to look at lines in absolute value, how they touch, because we've talked about those kind of equations, like an absolute value expression with a linear expression on the other side. But for now, let's look at 3x minus 2 and 5x plus 2. So if I do kind of a quick, kind of a somewhat sloppy graph here, and then 5x plus 2. It's going to be kind of like that. Not the best looking graph, but, just go with it. But Desmos will be more accurate, clearly. So I'll go with 3x minus 2. It's y equals 3x minus 2. And y equals 5x. And what was it again? Plus 2. And that's what intersect at negative 2, negative 8. So that's going to be a common point between the two. Negative 2, common negative 8. Okay. And then you could do this one here. We'll just actually do it by hand because it's kind of good to do it by hand to just, it's more tactile, I suppose, or kinesthetic. There'll be algebraic ways we'll do this, substitution or elimination. Elimination is a good technique if you see coefficients that are the same or just opposite sign, like see 2y, negative 2y. If I add these equations, you get 6x equals negative 3 because these cancel. X equals negative half. And you can throw it back into the equation to solve for the y coordinate. So in this case, elimination was better. You could substitute by isolating one of the variables if you want, but if you get fractions, that's not the best idea. Now this one, actually, y is very isolated for us. So I'd say substitution is a better way to go here. And we'll do this in more detail as a class, but you just replace y with that expression. So you replace y in the other equation with the y value from the equation that's very isolated for y. And then, yeah, work it out. And you get the answer there. And then you can get y afterwards. Here, you can graph the absolute value and then graph the lines here they touch. So we could do that in Desmos. But I'll just kind of do a quick sketch. I think it's going to look like this. And 2x minus 5 is going to look like this. So I think they touch once, but it could also do this as well. And move things around. And then switch the sign here to that. Multiply both sides by -1. So x will equal that junk. And x will equal the opposite of it, 2x minus 8. So you get x equals 8. Or here you get let me think here. 3x equals 8, x equals 8/3. And I think you're only going to get did I do that correctly? I think so. Seems a little off to me. Well, let's go to Desmos. That's probably our best bet. Okay. So 2x minus 5. Negative abs x plus 3. Yeah. I just didn't graph back. So yeah, so you get that. And the reason why 8 doesn't work, it's an extraneous solution. Because if you plug 8 back into the original equation, you get -20 on the left side, but -11 on the right side. By plugging 8/3, I think you get 1/3 in each case, which is fine, which is what you want. So that's something we'll talk about as well. We'll have these discussion topics we meet again as a class. But A basically is no, because it could be parallel or the same line. And again, we'll always have a solution. Again, if they're parallel, they don't have a solution. Absolutely, could touch twice, once, or never. They can miss each other. There'll be some word problems, which we've kind of talked about already. We'll go over that as a class. And there's more here. Linear system inequalities, I think I'm going to forego that. I was planning on doing that today, but we didn't. We did piecewise function instead. But yeah, just y equals mx plus b stuff. Sometimes you might have to make 2 equations, 2 variables. So we're going to go over all this stuff again as a class. Let's keep this video short. It's a weekend. Be beautiful weather, so enjoy it. And yeah, I think that's it. Done with the video.